So for our project for neural network, our title of the system is Student Performance Prediction System, where we used FNN feed-forward neural network to create the system. So we are from S2G1 Group B. So myself, Surya Varman Vijayaraja, and then Haras Hakim, and then Raja Hazman, and then Yogesh. So our team is consists of 4 members. So I'll say our project presentation for subject neural network BITI3133 S2G1 is supervised by Professor Dr. Burhanuddin. And then this video is strictly for education purpose only, and we are from UTEM. So I'll start off with our introduction. So the traditional assessment methods like exams and assignments often fail to capture students' learning preferences and behavior. So this project explores the use of feed-forward neural networks, which is FNN, to predict a student's CGPA based on factors such as gender, study hours, attendance, extracurricular activities, and social media usage. So by pre-processing and normalizing the data, the goal is to create an efficient FNN model for accurate CGPA prediction and compare its performance with traditional statistical methods. So next will be explanation on deep learning using Python. So first we use data preparation where you load the data, where we use pandas library to load and explore the data set. And then to handle the missing values, we remove the missing data to make sure the data set is complete and clean. And then to encode categorical variables, we we use features like gender and extracurricular activities to convert numerical values using label encoding. And then for feature scaling, we scale the numerical features using standard scaler to improve model performance. And then to split the data, we split the data into training and testing using train split function. And then model building with Keras, we define the model using sequential to stack layers of the straightforward neural network. And then to add layers, we use dense layers and then ReLU activation to apply hidden layers to learn non-linear patterns. And then for regularization, we drop out the layers to add prevent overfitting. And then for loss function and optimizer, we use mean squared error MSE to minimize the Adam optimizer for efficient training. And then for model training, we train the model using model fit where the data is fed and weights are updated through back propagation of the data. To monitor the overfitting, we use early stopping to stop training early if validation performance doesn't improve. And then for model evaluation and visualization to make prediction, after training, the model predicts CGPA using model predict on unseen test data. And then to evaluate the performance, we use mean absolute error to calculate the measure prediction accuracy. And then to visualize result, we plot the training history and compare predicted and actual CGPA values. So the key deep learning functions using TensorFlow and Keras are we use sequential, where to initialize the neural network as sequence layer. Uh, and then we use dense, where we create a fully connected layer, and then the neuron for each layer is connected, and then the ReLU activation also is activated to learn the complex pattern. And then for input, we use shape, and then to define the input shape for the model. And then it also helps to specify the number of input features for attendance, gender, and study hours. And then the next will be raw data description and download. We include data. The data set we included is from students with features affecting their performance. It contains both numerical and categorical variables used to predict the CGPA, and then the dataset features gender, which is male and female, which is also categorical, average attendance, numerical, study hours, numerical, social media hours, numerical, extracurricular, categorical, and CGPA.
The flowchart that we use for the project will be 8 processes. So the first one will be the understanding of data, and we load the data set from the Excel, and we examine the data types and the distribution and identify any missing values in the data set. And we will also analyze how different features like study hours and the attendance, social media usage, and extracurricular activities related to the target variable CGPA. And we also detect and handle the outliers. So we will identify any outliers in the data set, for example, study hours or social media usage that might be unusually high or low. And we will decide whether they need to be kept or removed. And second will be the data preparation. So the data preparation will be handling missing values. So we will also handle the missing values in the data set such as study hours or social media hours are handled using simple imputer with the median strategy to impute missing values. And we will also encode the categorical data. So for the gender and the extracurricular activities are categorical features. And the label coding encoding is applied to convert them into numerical values. For male equals to 1, female equals to 0, yes equals to 1, and no equals to 0. So the numerical features such as study hours and the attendance are normalized using standard scalar to ensure they are on a similar scale for improved model and performance. So third one would be the model design. So the model is built using sequential which takes layers in a linear sequence. And we also will using the ReLU activation for the hidden layers to introduce non-linearity and help the modern complex. And we will also drop out using a suitable regression task for predicting CGPA. And we also drop out layers are added to prevent overfitting by randomly dropping neurons during training, forcing to model to generalize the better. Fourth one will be the model training. So the model training will be, the model is trained using model fit with the training data, validation data, and a set of number epochs. And if early stopping is employed to stop the training when the validation loss doesn't improve for a set number of the epochs, preventing overfitting. And the fifth one will be the evaluation. So evaluation will stand for the prediction. After training, the model is tested on unseen data to evaluate its performance. And we are also using this learning process by plotting and visualization by using graphs. So the predicted CGPA values are compared to the actual values by plotting predicted versus actual CGPA to visually inspect the model's performance. And the sixth will be the reporting. So the interpret the training behavior including how the loss and main metrics evolve over epochs and if the early stopping was triggered. And finally will be the model summary. We'll also summarize the model performance, noting any strength and areas for improvement, discuss how the feature engineering and pre-processing steps contribute to the model's performance. And thank you.
Okay, for the coding part, this part we just load the dataset. For second part, yes, we select and rename the column into simpler column, simpler name. After that, we convert the attendance range to numeric because sometimes the attendance column has value like 70 to 18. This function can change, will change it into number by taking the average. Next part of coding is we drop missing and encode, which is any row with missing data are removed. Gender is changed from word to numbers, such as male as 1 and female as 0. Yes or no for extracurricular also turn into 1 and 0. And this part is features and target. X become as features and Y is the target. For this part, which is scale and split. For scale and split, we normalize the data so all the features are on similar range. This part will help the training. Then we split the data into 80% for training and 20% for testing. After that, we build and compile the model. This part will create neural network with 3 hidden layers. The dropout, which is here, dropout will help prevent overfitting. We use ReLU activation for hidden layer and linear output because CGPA is a continuous value. And then we go to train and evaluate. For this part, the model learn from the training data over 50 round, which is 50 push. We check how well it perform using the test data. The loss, this is the loss, tell us the average squared error, and mean absolute error tells how far off the prediction are. And for this part of coding, we predict from user. The program will ask the user to enter their own info such as gender, study hour, and others information of the user. Then it converts and scale the input just like we did from the dataset. Then it uses it to train the model to predict the CGPA for this input. And then it will print the result. Okay, we will run the coding. I already wait. We will run the coding. We will test the output part. Okay. It will ask the user to enter the gender. And then study hour and attendance rate. After that, social media hours per day. And last question. And then it will predict all the information given as 3.23 for the predicted CGPA. That's all for coding part. And then I want to ask question for Haras. Why deep learning is suitable for the project?
Deep learning is capable to learn the pattern data in complex data from multi-dimensional data, which a lot of features. So can proceed to the presentation data analysis with DL models and their output. To predict the student's GPA, we apply multi-layer perceptron using TensorFlow and Keras model, and then we train features like gender, attendance, study hours, social media usage, and extracurricular. As you can see, the slide shown the figure in scatter plot predicted vs actual CGPA value. So the diagonal line is means the indicate that the data point line on diagonal line mean there are no there are no bias and very accurate prediction. So, however, there are some deviation at the lower 2.0 until 2.5 and higher 3.8 until 4.0. So, 2.0 until 2.5 there are data point that lower below than diagonal line. That's mean if the model predict the CGPA is actually not accurate too much than to actual CGPA. So for the conclusion, this project is successful. Apply a multi-layer perceptron with deep learning and then using FNN network, FNN feed-forward neural network to predict a student CGPA. So technique like label encoding, feature scaling, dropouts regulation, and batch normalization help us to improve the model stability and generalization. And then our model is performed using evaluation metrics like MSE, MAE to indicate the accurate prediction. So we got the uh, we got the findings very accurate, not too much loss, not too much error. Overall, this project very highly using neural network theory, and then we assume this project is can be far better in future time, like apply hyperparameter tuning and feature expansion. So that's all for our group.